I go with these equations? Remember what I'm trying to work out? I'm trying to work out what angle should I fire at in order to hit this target. Any suggestions? We spent a whole double period on projectile motion? Yeah, Seb, what do you reckon?
Some coordinates 2000, 1000.
Good. So I know where I want to get to, right? Namely, like Seb said, these coordinates. Okay? So they're going to correspond to my x and my y. Okay? And you can see, by the way, as I put them in, I'm going to get values for t, which is going to lead into my next question. Okay? So x is equal to 2000. So let's pop that in. 2000 is equal to 200 t cos alpha. Okay, now remember, what are we trying to solve for? We're trying to solve for alpha in this case, right? So therefore, it's in my interest to eliminate t out of the next equation that I'm going to do this. This is sort of like simultaneous equations, if you like. A lot of simultaneous equations. They're all simultaneous. So this is into equation 1, right? I can simplify this a little bit. If I get t on its own, it looks like I'll have 10 on cos alpha. You happy with that? Divide all of those across. Yeah. Now I'm going to take this value and pop it into equation 2, right? Because I'll be able to eliminate some things here. So I've got y being equal to 1000, right? So if I take that into equation 2, I've got, 1000 on the left-hand side, which is equal to minus 5. Now, t squared, right? I'm going to put instead 10 on cos alpha. T squared. Okay. Here, plus 200, there's 1t there, cos alpha, sine alpha. Okay. So far, so good. What do I do with this? Well, I'm going to get, let's see here, minus 5 times 10 squared. So that's going to be minus 500 on cos squared alpha. Okay. Then here I've got 200 times 10, so that's 2000 sine alpha on cos alpha. Okay. 1000. Now pause for a minute. It's always important when you've got equations and they're quite messy, right? You've got to work out, what am I doing here? Well, I'm trying to work out an angle, right? So therefore, I'm going to be solving for alpha in a minute, okay? So what could I do to this mess to make it easier for me to solve in terms of alpha? Right, I want to choose some trig function that I can get everything in terms of, okay? This is a sec squared, and this is tan. Right? So I can convert everything into tans, right? Or into sec squared, it doesn't matter, right? So I could also divide through by 500, that'll make things a little neater. This is minus sec squared plus 4. Okay, so we'll get everything all on one side in a second. Sec squared alpha, what's it equal to in terms of tans? 1 plus tan, right? So this is minus 1 plus tan squared plus 4 tan alpha, and I might as well take this opportunity to take that 2 over. Okay? So minus 1, minus 2, minus 3. I can take out a negative 1, and then I'm in a position to factorize. So what's the factorization here? Minus 4 plus 3. Minus 3 minus 1. Okay, so that gives us 2 solutions for tan and pause. Now, what's this mean? We've got 2 solutions out here, which we sort of could have seen all the way up here because it's a quadratic, right? Does that make sense? Why would we have 2 solutions for? Okay, so here's our tank, right? One of the options, in fact, you can see this angle here, for alpha, you're going to get tan alpha equals 1, so alpha is going to be 45, right? Now this other angle, tan inverse of 3. I wrote it down. What was it? Has anyone got there before me? No, you're too slow. It's about 71. Okay. Roughly, obviously, because 3 is not an exact value. Both of these options work, because 45 means, okay, fire it, there you go, okay, that totally looks like 45 degrees. Alternatively, I could fire it at a much higher angle, 71 degrees, okay? So up it goes, whee, off the board, and then it comes back down and lands, okay? Both of those are fine. Yeah, does that make sense? Okay. So therefore, the question, what angle? Well, there's 2 solutions, right? So therefore, when I'm working out all these other bits, I'm going to get double up solutions for all of them as well.